see the slides that I'm sharing. You can also find the slides online. I've dropped a link in the chat for those of you who want to follow along on Google Slides. Feel free. You can also download the presentation from Google Slides. So welcome everyone. Please feel free to say hello in the chat anytime. Tonight, here is the agenda. First, we're going to introduce Lumiwealth and get to know some of you in the live stream today. Then we're going to introduce 4 key topics from our blockchain programming course. So the goal tonight is to tell you about blockchain programming and introduce you to some of the concepts like cryptocurrencies, smart contracts. So I will drop a link to the course in question for tonight. That way you can all check it out at lumiwealth.com. So we're going to cover why learn blockchain in the first place, what are 2 of the most popular blockchains, Bitcoin and Ethereum, how do smart contracts work? We'll take a look at an example of one. And what are some smart contracts that you could build, like cryptocurrencies and NFTs? In our blockchain programming course, we'll build lots of these smart contracts together for the Ethereum blockchain. So hello everyone, come on in. First, let's get to know some of you in the chat. We'd like to know something about you. That way we know how to tailor the webinar for the audience. So please let us know, what is your job? Do you know how to code? And how much blockchain experience do you have? Most of my students are complete beginners. So we do tailor the webinars and the courses to absolute beginners. But we need to know who is in the call and how much experience do you have? That way we can best tailor the experience for you. I will begin. My name is Alexandra. My occupation is that I am a software developer and instructor here at Lumiwealth. I have taught thousands of students online, just like you, how to build smart contracts and decentralized apps. So feel free to leave your own message in the chat here at lumiwealth.circle.so. We at Lumiwealth are an online school. We have courses primarily focused on the finance industry, like trading as a business, crypto trading with algorithms, algorithmic trading, options trading, and now we're getting into more of the blockchain space as well, like Web3 and blockchain programming. So we have some messages. Hi, I'm a backend engineer, but poor in understanding of crypto. Okay, sounds like you have some coding experience with the backend side. That will definitely help you build smart contracts because you have to use programming to build smart contracts. But no experience in crypto, that's totally fine. Poor understanding. We will help get you up to speed tonight. And then, of course, we'll teach you a lot more if you do take the course, which begins in September. We start our next session of live classes. We also have another message, Matt, NFT/crypto investor. No coding experience outside of small smart contract review. Looking to learn Solidity. Yes, Solidity is the coding language for Ethereum contracts, and we learn Solidity from scratch in the fall in this course. So a great place to be. If you have some experience investing in NFTs and cryptos, that will give you a leg up with the whole blockchain ecosystem. But our course is focused on building smart contracts in Solidity. So you've come to the right place. Antonia says, I am a graphic design freelancer. Let's see here. Chat is escaping me. Graphic design freelancer, don't have any experience. That's totally fine. Most of my students don't have any experience, which is why we start off with the complete fundamentals from scratch. And then each week we build more and more complex projects. But we start off at the very basics in week 1. Anton is currently in crypto trading with Robert. Awesome, here at Lumiwealth. Know some Python, started my NFT project. Smart contract is the biggest obstacle so far. If you do have some crypto experience, some Python experience, that will definitely help you because you've used Python for coding before, and smart contracts will be more coding. So yes, happy to help you understand the smart contract side. We also have Nathan. I'm a kitchen manager and want to learn something different. I have 0 programming experience, but own 9 different crypto coins and like blockchain. All right. Yes, most of my students, again, are in a similar boat. they usually have no programming experience or maybe a little bit. Gavin says, I'm a senior help desk technician, but I have a strong knowledge of crypto. Do you guys teach about the XRPL blockchain, the XRP ledger? In this course, we don't have any week that covers XRP, but I have taught it before and I'd be happy to answer any questions about it. But for this course, we focus on Ethereum only because it is the #1 out there for smart contracts. We also have Juan. I'm a beginner. I work for Instacart, no experience in programming. All right, thank you for commenting. Great to know. Sounds like most students here tonight are beginners, pretty usual. Brandon says, I'm halfway through Odin Project JavaScript path, want to learn more about Web3 and crypto. So if you do have JavaScript programming experience, that will help you. Solidity looks similar to the JavaScript language, but it is its own programming language with its own syntax, its own special features, and its own rules. But JavaScript is good because most decentralized apps, they are built with JavaScript. We have another course, Web3, and in that course, we focus on JavaScript to build dApps. I also have Rial. I work at your local warehouse, blue collar, hard work. Time for a change. My back always hurting. Oh gosh, well, thank you for commenting. And we're very happy to help students who are transitioning to new careers. Ira says, some JavaScript, Python programming, dip my toe in Solidity. Enjoy digital art NFT design. All right, dip your toe in Solidity. That's great. That means you have a little bit of experience. Glad to hear that. That will definitely help you get up to speed with smart contracts even faster. All right, thank you everyone for commenting. Feel free to comment anytime tonight and ask a question anytime. We're also on YouTube, so if you would like to watch back this webinar or watch our other webinars, then you can find them at youtube.com/c/Lumiwealth. Please subscribe and hit the notification bell. We post webinars and interviews and reviews of previous students. So please feel free to watch on YouTube anytime. We're also on Circle. Of course, if you're watching live, then you know that. And we are on Discord if anyone is still using Discord. We're moving more towards Circle, but we do still have Discord if you want to message us there. All right, now that was our introduction. Next, let's get into our first topic of the night of our 4 main topics. Let's talk about why learn blockchain in the first place. So we've created this course, Blockchain Programming, running for almost a year now. So let's talk about why we started this course and why you should want to add blockchain to your resume in the first place. Well, blockchain is a relatively new field. The first blockchain was created back in 2008, and Ethereum was created in 2015. So it's a relatively new technology. That means there's still a lot more to be created, invented, and a lot of projects that you can create that will be new and cutting edge that have never been seen before. So it's an exciting space to be in. There's a high demand for blockchain developers because it's such a new tool. You know, maybe a company has a lot of software developers who know general programming, but they have none only that are specialized in the blockchain. Blockchain is affecting the world in different industries. Most of you are probably familiar with cryptocurrencies. Some of you said you have invested in cryptos, NFTs. So these are the 2 most popular ways that blockchain is affecting the world. Cryptocurrencies, digital currency backed by cryptography, like Bitcoin, ETH, and many, many more. In our course, we're actually going to learn how to build our own cryptocurrency token. And of course, NFTs, another very popular method of how blockchain is affecting the world. Non-fungible tokens. Usually they're used to represent some kind of tradable, collectible art asset, but they can also be tied to functionality and have some software behind them. So those are the 2 most popular ways that blockchain is currently being used today. But with smart contracts, which we will talk about shortly tonight, we actually can do a lot more with a blockchain than just create a cryptocurrency or an NFT. We can build smart contracts which can hold any business process or any piece of software. If you're familiar with coding, as some of you mentioned you are, a smart contract is like a class, a piece of code of the type class, where you can define an entity or a business process like an online school or an NFT or a bank. You can define it and write out all of its properties and behavior in code, and then put it to live forever on the blockchain. And these smart contracts can represent anything. Commonly, they're representing a cryptocurrency token or a non-fungible token, but they can represent any kind of entity. That's why you see companies integrating blockchain technology into their current system, into their current software, because they take advantage of these smart contracts where they can write a business process like their online school and signing up users, handling payments, tracking progress. You can write all of that and handle all of that with traditional software, but you can replace that or add on to your existing software to include storing all of that code and all of that whole process and running that whole process over the blockchain instead. And we'll talk about some of the reasons why a company would want to do that, why they would want to take their existing process and put it onto Ethereum. So those are some more ways that blockchain is affecting the world. And in our course, we focus on cryptocurrencies, NFTs, but also other types of smart contracts, like building out a bank where you can store bank accounts and you can handle deposits, withdrawals, taking out loans, building all that functionality and putting it on Ethereum. Because any type of software you can put in the form of a smart contract and then put onto Ethereum. Some examples are integrating the blockchain smart contracts with video games, websites, which brings Web 3.0, and financial instruments. So any type of existing industry that uses software, whether it's a website, which uses software because websites are made up of code, or even something like the music industry, if it uses software, the blockchain is just another piece of software, another type of software, meaning it was written with code. So we can integrate an existing company or make a completely new company. We can integrate its software, which might be a traditional piece of software, like just a website. We can start to integrate it with smart contracts from a blockchain like Ethereum. So that's how we see blockchain affecting the world. And that's why we see this demand for blockchain programmers, not just to build cryptocurrencies and NFTs, but also to change or add on to a company's existing structure. And of course, blockchain is affecting the world in transactions. The final point here in the list. Back when Bitcoin first came out, it didn't have much perceived value. You couldn't go to a store and buy something with Bitcoin, but these days, more and more companies, large and small, are accepting payments in Bitcoin or other cryptocurrencies, whether it's online or it's offline at a real walk-in coffee shop, for example. So we see more and more decentralized technology being used day to day and in existing pieces of software. That's why you may have seen some large companies take on Web3 programmers, blockchain programmers, and this is the reason why they're starting to implement decentralized technology. And we'll talk more about some of the benefits shortly. Blockchain is also called the future of the internet because of how it affects the ability to build websites. So a website, as I mentioned briefly, is a piece of software because it's built with code, and you can integrate a website with a smart contract on Ethereum, thereby taking advantage of all the benefits of Ethereum. And as more and more websites are using smart contracts or other decentralized technology, this changes net is run, because it changes how websites are created and how websites function. So that's why blockchain is also sometimes called the future of the internet, because of Web 3.0. So back in the 80s, when the web first came out, we were in the general phase Web 1.0. And then by the year 2000, we got into Web 2.0, which is our current phase. With Web 2.0, there's more websites being created, more data being created as well, usually through social media websites. But there's also companies with large monopolies over the web and the data that is being created and generated. And so the aim of Web 3.0, the next general phase of the web, is to create a more decentralized web, meaning that what's being done with your data is more transparent. Companies have less of a monopoly on the web. And so therefore, it's easier for a smaller company to get started and to start running and not get completely monopolized by one of these large companies we currently have in Web 2.0. So with this next transition into the next general phase of the web, Web 3.0, blockchain is playing a large role in that transition. That's why it's called the future of the internet. Before we continue, we have a question from Nathan. Is Ethereum more efficient than Bitcoin? So we're going to talk about Bitcoin and Ethereum next, actually. So hold that thought. Before we jump into that, answering that question, 2 more points of why to learn blockchain if I haven't said enough to convince you yet. Another reason to learn blockchain is to make better investments. Some of you mentioned that you've invested in cryptos and NFTs, you own some cryptocurrencies. If you learn blockchain programming and how the behind the scenes of it all works, how to read a smart contract, how a piece of software like the blockchain works, it will help you make better investments, because you can actually read what the contracts are doing, what the company is promising. You can see the code behind the coin and all of that. So it will help you make smarter investments. And there are good job prospects by learning blockchain programming, because as I already mentioned, there's a high demand for blockchain programmers and Web3 developers. Now let's get into Bitcoin and Ethereum specifically. So in this course, we're going to build smart contracts for the Ethereum blockchain, because it is the most popular one for creating smart contracts. Back in 2008, the first blockchain was created. This was Bitcoin. So with the invention of the Bitcoin blockchain also came the invention of the Bitcoin cryptocurrency, which was also the first cryptocurrency. And since then, other blockchains have also been created. For example, Ethereum was created in 2015. The goal of Ethereum was actually to increase the power of a blockchain, so to expand the ability of a blockchain. Ethereum, Bitcoin, and other blockchains like Cardano, Solana, they're all still blockchains. They all have the same general structure because they're all just code, but they have the same general structure because they're called blockchains. But each one has its own key features that make it unique. So Ethereum was specifically created to add new features. The most important feature that Ethereum added was smart contracts. So with the Bitcoin blockchain, you could not create smart contracts to write something like a bank and put it onto the blockchain, or to write an online school and put it onto the blockchain. But with Ethereum, it actually invented smart contracts and it invented Solidity. With Bitcoin, you can only create simple scripts if you want to represent a process, but it's not very powerful. So is Ethereum more efficient? Let's see. Well, efficiency is usually related to producing an output. So in that sense, I would say yes, it is more efficient because it does produce more of an output, in that if you're going to build a smart contract, most of the time you're going to be building it for Ethereum. You can build it for other blockchains as well because new blockchains are created over time. But currently today, Ethereum is the most popular one. We also have a question from Gavin. Are there opportunities to work remotely in blockchain? Definitely, I work remotely and I work in blockchain, so there's an example for you. A lot of companies, especially since 2020, they've gone to work remotely. If you're working in software, which blockchain is software, then there's going to be high opportunity to work remotely. Great question. Matt is asking, energy, yes, once the merge is complete and they go from proof of work to proof of stake, will be more efficient energy-wise. That's referring back to Nathan's question. Is Ethereum more efficient energy-wise in terms of the computational power? So in terms of energy-wise, their base structure is similar in terms of their proof, but as Matt is saying, Ethereum is some changes in how their proofs work, which refers to the actual system of the blockchain itself. So once Ethereum does implement those changes, then yes, it will be more efficient energy-wise. Great comment. Thanks, Matt. All right, so now we know Bitcoin and Ethereum, but what is the underlying structure of a blockchain itself? So a blockchain is a piece of software, which means it was written with code. A website is also a piece of software because you create it by writing code. Even if you use an online generator to create a website, behind that, there's still code. An app on your phone, that is also software. It's written with code. A video game, anything written with code is software. So a blockchain is also written with code. Therefore, it's also a piece of software. But it's the actual structure of the software, what it looks like, what the code looks like, how the code is structured, and what its purpose is, what it can do. That's what makes it a blockchain specifically than just a website or an application. So a blockchain has many properties. To visualize a blockchain as a metaphor, you can imagine a chain of blocks. So you have a bunch of blocks and they're all connected through a chain, and the chain can never be broken. And in each block is data, meaning information. The information is about what happens on the blockchain. So every time something happens on the blockchain, that gets recorded and it gets put into a block, and the block gets added to the chain. So every day, more and more blocks are being added to Bitcoin, to Ethereum, because if I create a new smart contract and I put it on Ethereum, that action gets stored. Everything gets stored. If I want to buy an NFT from Ethereum and I buy it right now, that transaction, it also gets stored. So everything that happens on the blockchain gets recorded. So you can visualize it as this chain of blocks, but it's not actually a chain of blocks anywhere. It's not actually being stored in a warehouse or in some kind of, central location. That's just a visual metaphor for the code that's actually running. A blockchain, if it is decentralized, does not have any CEO or any central entity like any company that's running it. Bitcoin and Ethereum, they are decentralized, meaning there's no central location that's running the blockchain. Instead, the way that Ethereum is running and that it's staying alive, that it can actually handle transactions, is through a peer-to-peer network. This means a network of computers around the world. And so these computers, they keep Ethereum's process running because they're responsible for adding new blocks to the chain, for handling transactions or interactions and adding them to the chain. So every time you want to do an action on Ethereum that changes Ethereum, like you want to create a new NFT, that has to get put in a block, and before that, it actually has to get validated first to be checked to make sure that you have enough funds and that you are a valid account, and check for fraud. And that whole action, the handlers are those peer-to-peer nodes in the network, the computers around the world. And if you wanted to, you could actually connect your computer to join the network, and you could help Ethereum run. And you would get rewarded with a small amount of crypto occasionally. This used to be a more profitable venture than it is today because there's a lot more popularity in it today. So that is how Ethereum is being run. There's no CEO. There was a creator, but there's no CEO currently that is keeping it running, and no warehouse where the data is all being stored. Instead, it's the peer-to-peer network. So if you wanted to become one of the nodes, then you could use your computer and join the network. I would recommend using an older computer that you don't use anymore because it would use up a lot of your computer power, a lot of the computational power. So that goes back into Nathan's question and Matt's comment about energy. If you connected your computer to the network to get those rewards to keep it running, it would take up your computer's energy. So that's how Ethereum runs, is on that computer energy. All right, so that is an overview of that chain of blocks. And why was this created in the first place? Why was this type of software created? Well, a piece of software like Ethereum has several benefits of why you would use it. Number one is, of course, cryptocurrencies, to be able to have a digital currency backed by cryptography. And we'll actually talk more about that later on tonight. Another reason of why you would want to use Ethereum is to establish trust for a transaction or an interaction. For example, if I wanted to purchase a house, then with traditional software, you would have to establish trust between yourself, the buyer, and the seller of the house. And you'd usually involve some lawyers, your bank, you'd have to take out a loan, most likely. You'd have to sign a contract and make sure it's legally binding so that if I send you the money, you'll send me the house, and it will be a valid transaction. That I'm not going to run away with the house and you're not going to run away with the money. So you have to establish trust with traditional interactions. The goal of the blockchain is to make that process faster by getting rid of the intermediaries, which also makes it cheaper. So instead of having to involve third parties to help establish trust in the transaction, instead, I put all my trust into Ethereum itself, or whatever blockchain I'm using. Because the whole contract for the transaction is going to be written as a smart contract that lives on Ethereum. So in that smart contract, everything's written out that if I send you the money, I will get the house and the ownership will be transferred. And more states are adding smart contracts to be legally binding now in the real estate industry, in this example of buying a house. So the point is to have a faster transaction and have a cheaper one because you don't need to pay the intermediaries in this case, in this example. So all my trust is in the smart contract. And we're going to talk more about smart contracts coming up next. But the reason I can trust the smart contracts is because they are transparent. They are available for everyone to read on Ethereum. So you can't hide anything in the contract. It's permanent and open on Ethereum. So that's how we can establish trust. And it doesn't have to be a transaction, literally, like I'm buying something from you. It could be some kind of interaction, like if I want to sign up for your online school. then that sign-up process could be done over Ethereum. So it doesn't have to be a purchase. It's any kind of interaction. And if you're doing it over Ethereum, then you can establish trust that the interaction will be valid, it won't be fraudulent, it'll go through successfully if you fulfill its requirements. So both parties can establish trust in each other through Ethereum. So I don't have to trust the buyer or the seller. If I'm the buyer, I don't have to trust the seller to give me the house. All I have to do is trust the smart contract, because I'm not even interacting with the seller at all. I'm only interacting with the contract which the seller created. So I can read the contract, and if I'm satisfied with it, then I send my funds for the house to the contract, and the contract will do exactly what it says. And if I'm not satisfied with the contract, then I don't have to send my crypto to the contract. So in our course, we're going to learn how to understand these contracts and how to create them ourselves. So I don't even have to talk to the buyer ever. I just have to interact with the contract. So that's the number one most useful property of a blockchain. A blockchain is also called a timestamped series of immutable transactions. Timestamped meaning that everything that happens will be given a date and a time, and that happens when it's added into a block at the end of the chain. And it is a timestamped series. A series just means a list. So if you have experience in programming, maybe you've heard of a linked list. This is a list of items and they're all linked together. So it's the same idea here. You have a bunch of blocks and they're all linked together. The series is immutable, which means it cannot be changed. So once I put up a contract, I cannot change the contract in any way. So that also helps establish trust, because I know that the seller is not going to edit the contract at the last second and then run away with all my money, because the contracts are immutable. They cannot be mutated or changed. And the series is a series of immutable transactions. Transactions could be a purchase, but it could just be any interaction. It's called a transaction because if you're interacting with Ethereum in a way that changes Ethereum, then you have to pay a small gas fee for that interaction. So that's why every interaction that changes something, like creating a new token or transferring an NFT or publishing a new contract, all of that is changing something in Ethereum. Therefore, it's called a transaction. And a blockchain is managed by a cluster of computers using special computer algorithms. So proof of work, proof of stake. How each blockchain works can vary depending on if it's Bitcoin, Ethereum, Solana. But at the end of the day, they still have the same base structure, this chain of blocks. So that is an overview of what is a blockchain. Next, let's talk more about smart contracts. So we've covered these throughout the night already, but to review, a smart contract is a piece of code that you put onto Ethereum. With the invention of Ethereum came the invention of smart contracts. So this could be a contract that sells a house, or a contract to represent an NFT, or a new cryptocurrency token, or a contract to represent a bank, and more. It can be a financial instrument, which is why you commonly see contracts implemented in the finance industry, but it doesn't have to be a financial contract. It can be an online school. It could be a video game represented in a contract. So any kind of software. A smart contract is like a regular contract in that it is an agreement, because once you publish a contract, you're agreeing that perform its tasks and that it will do what it says. Because once you publish it, it's now out of your hands. It's autonomous or self-running. So if I want to sell my house and I write a contract for that sale and I put it on Ethereum, I don't have to work with the sale anymore. I just have to wait for the money to come in and the ownership will be transferred automatically because the contract will do everything for me. We have a question from Dennis asking, every node receives a gas fee. So a node refers to one of the computers in the peer-to-peer network of nodes. And each node is keeping Ethereum running, but it doesn't get the entire gas fee. It will get a portion of it occasionally, but your question, I want to say yes in a way, because when you pay gas fees, it is to pay the nodes. But every node does not get paid the whole gas fee. If you are a node, if your computer is a node, you'll get rewarded occasionally with Ethereum, but it won't be as much as getting the entire gas fee. Instead, you get rewarded randomly. But yes, that's the reason why we have to pay gas fees on Ethereum, is to pay all those nodes that are running the network. Great question. Please feel free to ask for clarification if needed. All right, so that is a contract, a smart contract. And in our course, we're going to learn how to build different types of these smart contracts, like a smart contract for a cryptocurrency token, a smart contract for an NFT, smart contract for a bank, and more. Solidity is the programming language or coding language that we will learn. So Solidity is the #1 language for writing these smart contracts for Ethereum. You cannot write a contract in English for Ethereum. It has to be written in code. And if you know one programming language, you're going to find it easy to pick up another one. So if you learn Solidity, you'll find it easy to use another language for maybe a different blockchain or even a different software project. But it is still its own language with its own rules. But if you do have experience, like some of you mentioned, you have experience in JavaScript, Python, that will help you get started, because at the end of the day, Solidity is a programming language, so you'll see a lot of common programming topics or features like variables, functions, classes, which are called contracts in here. And it's easy to get started. If you want to try out building your own contract, there's actually an official online code editor for Solidity called Remix. So I've dropped a link in the chat, remix.ethereum.org. Here you can actually get started with building out some smart contracts and even deploying them, sending them to a blockchain. So here on Remix, you would go to your file explorer and you can create a new file. You would create the file extension .sol, which is Solidity. So just like how I would create a text file and I would have the extension txt, when you're creating a smart contract, it will be a Solidity file, the extension SOL. So here is an example of a simple contract. Of course, contracts can get much more complex than this, and they do. But for the purposes of tonight, here is a simple example of a contract. We have a question from Stephen. How do you take the Remix live? And are we creating our own coin or just a class demo? Okay, how do we take a Remix live? So if you want to publish your contracts to the main Ethereum network, then you would have to go through your terminal and do that, which we will learn in our course. With Remix, if you want to test out your contracts, you can go to this third icon, which is the compiler, and first compile your contract, which means you're going to have it be read by the compiler to have it checked. If you get a green check mark, it means you're good. If you have some kind of issue, it will be mentioned here. You can also pick the contract that you want to compile. Make sure you chose the right one. And then you can deploy. So that's the last icon here. You can actually deploy your contract. And the environment is Remix Virtual Machine. So here we can pick the contract that we want to deploy. And this is how we can test it out. You'd have to enter any deployment requirements and then publish it to this test network. So on Remix, we're not actually publishing to the main Ethereum network. We're just running a simulator. So I can enter here a name like Lumi NFT and then a symbol, hit transact, and then you'll see your deployed contracts at the bottom here, which contains all of the details about the contract. So you can then interact with the contract. Another question, are we creating our own coin or just a class demo? So right now, this is an example of an NFT. In the course, we will create a cryptocurrency token. And in the class, we do a class demo, but you can easily modify it and change its name, change its properties, and you can have your own coin. It'd be very easy to take the class demo and then to modify it to become your own coin. Juan is asking, is there any type of special CPU or GPU? Here on Remix, there is no GPU. Just your basic CPU. I haven't actually checked into that, but I've never seen there to be a GPU on Remix. But it's usually quite fast because everything is running locally. So I haven't had any issues with speed of deployment here on Remix. So that was an example of writing a contract and then putting it onto Ethereum. And in the course, we'll learn how to actually put it onto the main network. But Remix is just a simulator for you to try out writing out a contract and then interacting with it as though it were on the official main network. But if you do want to publish your contract to the main network, you would have to pay a gas fee. So that's why we're just starting with the simulator first. Then you can also go to a public network for testing, which is free. It just requires test Ethereum, which you can get for free. And then when you're satisfied with your contract, you can then publish it to the main Ethereum network, which you would have to pay the gas fees to do that. So in our course, we're going to start off with the simulator and then learn how to go to a public test network, and then very similar steps to go to the main network, but you would have to use real cryptocurrencies. All right, so this example is Solidity Code. So don't worry if you're confused with the code right now. It's totally normal because you probably don't know Solidity at this stage, but by the end of the course, you'll be able to create contracts like this and much more complex too. But to break this down, at the top of the file, we have the license identifier of the file. So is the contract copyrighted or is it open for copying? Then you have the version of Solidity that the contract uses. Solidity is an evolving language. So back when it was first created, it had version 0.1. And as it gets updated and developed, it will increase in versions. And this is very normal with any programming language or piece of software that you're using. So that's why at the top you specify what version of Solidity are you using, because maybe in 5 years there will be a different version and the Solidity compiler for version 3 will not work for your file that you created 5 years ago. So that's why you have to specify which version of Solidity so that it is read properly by the correct compiler, which is like the reader that checks your code and also converts it. Then you can import any helper files that you're using. So commonly in development of coins or NFTs, you will use a template like this one. It's very common to make sure that you're following the correct rules for your NFT and that your coin or NFT, it will work on different marketplaces that you're not lacking any security features. So this is very common. You'll see using a helper file, which you import, and then you can create your contract. In this case, the contract is called Lumi NFT, and it's using this helper template. And then we just have a little bit of code inside of the contract, which is required for the contract to run. But most of the actual NFT code is here in this helper file. And this constructor inside of the contract is saying that if you want to create this contract, if you want to put the contract onto Ethereum, then you have to give the NFT a name and a symbol. You saw me do right here. I put in the name and the symbol. But most of the code behind this NFT, most of this functionality, it comes from the helper file. So in our course, we're going to learn how to build our own contracts, how to use helper files, and so on. Matt is asking, are helper files what they refer to when I hear about dependencies? Let's see. A dependency would be very closely related. A dependency is something that your project depends on. So it is very closely related. Like if my project relied on another piece of software to work, then that piece of software or that library, that tool, it would be a dependency. So in this case, the dependency is actually the provider of the helper file. The helper file itself is just an imported file, but the provider of that would be a dependency because my project is depending on that provider to actually run. If I cut this out, then suddenly my project will break. So yeah, the dependency would be the provider of the helper file. Great question. So let's get more into the nitty-gritty, the terms in programming. And we're going to learn a lot of programming terms when we start this course again in September, very shortly, actually. All right, so this is an overview of a simple contract. And if you want to put it onto Ethereum, this is called deploying it. You can put in a new name and a new symbol, hit transact, and that will deploy the contract again. Each time you deploy, you're actually putting another instance of the contract that is completely unique. So you can actually write one contract and then put it on Ethereum 100 times. And each of those 100 times, it's a unique instance that operates individually. Because, as I mentioned before, you can never take anything back if you're working with the Ethereum main network or any public network. You cannot take it off. But you could create it again and again and again. You just cannot undo the creation. So that is how you can get started with coding in Solidity. And maybe some of you recognize some of this code from other languages, but Solidity does have its own unique features that make it different from other programming languages. So in our course, we're going to teach you Solidity from scratch, from the very basics, starting in week 1. And you're also going to learn in general programming through Solidity because it's still a programming language. So it has a lot of commonalities with other programming languages, but it also does have its differences. And here's an example of that code if any of you want to try that out again anytime. You can go to the source files and I can drop that link again in the chat. All right, so that was an example of Solidity. We're going to be coding a lot in the course. It's a very hands-on project-based course. Now let's get into our final topic of the night, cryptocurrencies and NFTs, because in the fall we will learn how to build a crypto token and an NFT. It's a couple of our projects that we will have. Let's start with cryptocurrencies. likely most of you have heard of cryptos. Some of you said you've invested in cryptocurrencies. So cryptocurrency is a digital currency backed by cryptography, hence the crypto part in the name. With the invention of the Bitcoin blockchain back in 2008, also came the invention of cryptocurrencies. So the Bitcoin cryptocurrency was the first cryptocurrency created. But since then, there have been many more cryptocurrencies created, like Ether for the Ethereum blockchain, ADA for the Cardano blockchain, Sol for the Solana blockchain, and many, many others. You can even create your own if you wanted to. Cryptocurrencies are different from a digital dollar or a traditional piece of digital currency, because cryptocurrencies are actually backed by cryptography or secured by cryptography. How? Well, because they're backed by a blockchain and they're tracked by a blockchain. So the Bitcoin currency, for example, every Bitcoin or fraction is tracked. So if I own 1 Bitcoin or maybe half, and I want to spend it at your online store, then the blockchain will track where that exact coin went. It was in my account, and then now it's in your account, and the whole history is tracked in the blocks. So this makes it very hard to counterfeit or make a fraudulent transaction, at least compared to a digital dollar. Something like buying something with my credit card or another form of digital currency, it's easier to double spend it or to make a fraudulent transaction. Whereas with a cryptocurrency, it is much harder. Before any transaction goes through on a blockchain, it will get checked and validated by the nodes. This also helps to reduce fraudulent transactions, because if I want to buy your house, it doesn't just get bought immediately. First, the nodes, they will check, do I have the money? Am I trying to double spend the money, or do I actually own that money? Is it valid cryptocurrency or is it fraudulent? Am I a valid account or am I a potential spammer? So before transactions go through, they are validated, and this also helps to reduce all these counterfeit transactions. It's not impossible, but it is nearly impossible. It's what we say. Now, cryptocurrencies were actually a unique feat in computer science because they solved the double spending problem in computer science, which double spending leads to a lot of money loss and fraud. So to explain double spending, if I want to send you an image like this image here of an NFT, I can just text you or email you a copy of the image. And then I have my copy and then you have your copy. But with money, you cannot do the same thing. I cannot send you a copy of my money. If I did so, that would be double spending. Double spending is actually a huge problem with regular digital money. But with cryptocurrencies, it's much harder to double spend for all the reasons that we just mentioned. So that's an introduction to cryptocurrencies. And that's why people care about them and why companies are starting to integrate technology to enable people to pay in cryptocurrencies. And a lot of financial companies are interested in cryptocurrencies because if you are an institution that's transferring a lot of money, something like a bank, then you're going to be at high risk of attacks and fraud, especially even more so than a regular company. So that's why there's a special interest in the financial industry for the blockchain. Now we have native cryptocurrencies versus cryptocurrency tokens, and there's a distinction that is to be made there. If you're creating a native cryptocurrency, it means that it is native to its blockchain. It means that it is directly tied to a blockchain and it is used to pay the gas fees. For example, Bitcoin is used to pay the gas fees on the Bitcoin blockchain. So every time you do a transaction, you have to pay a small fee in Bitcoin, and that fee is used to reward the miners or the nodes who are mining away and keeping the blockchain running. They're mining cryptocurrencies, which is more into how the actual blockchain itself is running, the actual structure of its software. And on Ethereum, to pay gas fees on Ethereum, you have to pay with Ether cryptocurrency. You cannot use any other cryptocurrency. So a native cryptocurrency, it is directly tied to a blockchain. And you can build your own cryptocurrency, but you would have to build your own blockchain too, if it is truly a cryptocurrency in the traditional sense. And this isn't as hard as it may sound. You can clone open source blockchains out there, which means that they're free for copying if you were interested in creating your own cryptocurrency like Bitcoin. Similarly, we have cryptocurrency tokens. So these are also digital currencies secured by cryptography, but there's a slight distinction in that they're not paying gas fees. They are built on top of an existing blockchain instead. And they can be used for buying, selling. So they can be used as a currency, but they're not actually paying any gas fees. So it's a slight distinction. If you want to create a cryptocurrency token, you don't have to create your own blockchain. You can just build it on top of Ethereum. And you do that by creating a smart contract. So you would create a smart contract just like we have here, but this one is for an NFT. Instead, you would create one for a cryptocurrency token. So in our course, we'll learn how to do both. So that is cryptocurrencies, and then cryptocurrency tokens, which are very closely related, very similar, but there's just this small technical difference. All right, next, let's talk about NFTs. NFTs are another type of token. So we have cryptocurrency token, and we have non-fungible token. To create an NFT, you could go through a website and create one there if you're using the help of a dApp like OpenSea. Or you could go directly to the blockchain and create one yourself through smart contracts. So if you ever have made an NFT yourself, you've probably gone to a website and then created the NFT like that. In that case, the website is the decentralized app, which means it's just the interface for you to interact with Ethereum. But if you want to go through Ethereum directly instead of going through a third party, then you can create a smart contract. So just like we have here in the previous slide, this would generate an NFT, and then tokens of that NFT could be minted. Okay, we have some questions. Dennis asks, why create currency if tokens have no gas fees? Great question. Well, it's much easier to create a cryptocurrency token, and it still has the same features. You can still use it for being able to buy assets or sell assets. So if you want to create a new cryptocurrency, maybe Lumicoin, if we want to enable purchases of courses in cryptocurrency, we could enable buying that with Bitcoin, with Ether, or with Lumicoin. So that would be the reason, is to create it much faster without your own blockchain. Oh, Nathan's suggesting more control. Let's see, more control over the currency. Well, to have complete control, you would actually want to create your own blockchain, because then you have the cryptocurrency and the blockchain, but it's not required, it's not necessary. You could create your own crypto token on top. So in that case, for someone to want to buy Lumicoin, they would have to pay for it with whatever is the blockchain's currency. Like if I put Lumicoin onto Ethereum, then you could buy Lumicoins with Ether cryptocurrency. But then once you have it, you can then use the Lumicoin as its own token. So it would be if you wanted to create your own type of cryptocurrency in the fastest and easiest possible way. And it would still be a cryptocurrency, but you just wouldn't have to have your own blockchain. Another reason is if you want to enable transactions on a specific blockchain. So if I create my own cryptocurrency on my own blockchain, then I cannot actually transfer that to a different blockchain. So if I create LumiCoin on its Lumi blockchain, it can only be used on Lumi blockchain. So if there are some smart contracts or NFTs that live on Ethereum, I cannot buy those with LumiCoin because LumiCoin is only on Lumi blockchain. Every blockchain is different and cannot interact with each other. There is a way around that with wrapping, but it's less convenient. It would require more work. So that would be another reason for creating a cryptocurrency token on top of Ethereum, so that way you can use it on Ethereum. Another question, would layer 2 coins be able to be used for gas fees such as sushi for Ethereum? No, only Ether at this time. Great questions. Hopefully now you understand the difference. Cryptocurrencies on their own blockchain, which can only work in that blockchain, versus a cryptocurrency token, which is built on top of an existing blockchain, like a popular one like Ethereum. And then now you have a cryptocurrency token that people are using on an already popular blockchain. And then we were talking about NFTs, non-fungible tokens. So they're still tokens because they're still created with a smart contract to represent an entity. But the difference is a cryptocurrency is a fungible token. A fungible token means that it can be divided into smaller units. And on top of that, a cryptocurrency is interchangeable. If I give you 1 Bitcoin and you give me 1 Bitcoin, we didn't lose any value except in the gas fees. But the 2 Bitcoins are exactly identical in value. However, if you have 2 NFTs, then they're going to represent something different. They are individual, meaning with NFTs, we care about which ones do you own, which NFT do you have. But with cryptocurrencies, we care about how much do you own, how much Bitcoin do you have in your account versus which NFTs do you have. So NFTs are usually for collectible assets. Very commonly, we see them to represent artwork and just used as for trading value. However, it depends on the NFT. So most of them are very simple because that's the easiest one to create. However, with code, an NFT can actually have behavior. It can do stuff. For example, you could connect an NFT to a piece of software like a video game where if you reach level 100 in the video game, a new NFT is created and awarded for you, and you'll have that stored in your cryptocurrency account. So you can actually combine NFTs with other pieces of software like a video game or an app, a website. In the code for the NFT, you can also add behavior or properties. Like you could store different file types like a music file, a PDF file in the NFT. You could also specify some behavior like the NFT will change after 1 year, and it's all going to be there in the code for everyone to see. Or that the NFT enables you to do something on your other platform, like your website. So the most common format for NFTs is just images. Like if you go to a popular marketplace like OpenSea, the largest NFT marketplace, you'll see most of them are just going to be for collectible ownership and just trading to get money off of the trades. But you can create more complex NFTs. One example is in the metaverse, like Decentraland, virtual land. Let's say you have a land that is 100 by 100 units long, or maybe 10 by 10 to make it a bit simpler. 10 by 10, that means we have 100 land plots in total. So if I want to sell my plots of land, I can turn each one by one plot into an NFT. So if you have the NFT for plot 1-1, then you have that first plot. Maybe it's the one that gets the most visitors because it's the first one that people get sent to, or it's the most prominent one on the map. So NFTs can be used to represent digital land ownership. They can be directly tied to ownership of a real world asset or a digital asset, or they could not be tied to anything at all. They could just be whatever the NFT is itself, like a piece of art. But that land ownership one, I like to use that example because if you own plot 1-1, it's different from if you own the one right next to it. So with NFTs, you can represent ownership. And it's going to be permanent ownership, transparent ownership that gets tracked over time because it's all being tracked and stored on Ethereum. So with NFTs, we would use them to represent ownership. This is a very common use case. A cryptocurrency, it cannot be used to track ownership. Just because you have 100 Bitcoin does not mean that you have the plot 1-1. No, instead, if you buy NFT 1-1, then you have that plot of land. So different types of tokens for different purposes. And of course, more token types are being created over time, but currently cryptocurrency tokens and NFTs, those are the two most popular and prominent tokens that are created. But you could create a smart contract for any kind of entity or asset or business or process, because a contract can have properties like a name, an image, a description, but it can also have behavior. It could do things, just like how at your online school, you could create a new account, you could sign up for a course, you could watch a lecture. You can write all of that same behavior into a contract. And then that means that all of the actions are going to be handled autonomously through the contract. So you can actually replace your whole business to be running on Ethereum instead of your current structure, or you could add it on as a second layer. So lots of opportunity. All right, so that was an introduction to NFTs. Next up, let's go into the course curriculum for our course. Also, we do have a Labor Day sale, so you can save 25%. I'll drop the code into the chat. So please take advantage of that before next Monday. Also, if you buy 2 courses at once, you will automatically get 10% off. And I recommend the Web3 course because it is in the same ecosystem of blockchain. So let's go to lumiwealth.com and talk about the 8 weeks of this course. We have 3 different plans for the course: self-directed, live classes, and project help or tutoring. So you have 3 different options that you can choose from. With the self-directed plan, you're going through the course on your own. We have almost a year's worth of videos that you can watch. You get lifetime access to the whole video library. So you do not just get 1 semester, you actually get all of these semesters, past, present, and future, as we update. You also get lifetime access to the library of code, the Lumiwealth community, instructor support, and weekly discussion hour. So that is the self-paced plan. We also have the live classes plan. You get everything from the self-directed plan, but you also get 8 weeks of live classes. So if you need that extra motivation, then pick live classes. You can also ask questions live during the class, just like we had tonight. You'll also get 6 hours of dedicated live Q&A, access to all future videos and code, help with 2 personal projects, get to know classmates, resume and interview prep, and unlimited email and chat Q&A. And the third option is project help or tutoring. You get everything from the previous 2 plans. You also get help with building a custom project, including software development, and 10 hours of one-on-one video sessions or software development time. So if you need help with a specific project, or if you just want that extra one-on-one tutoring, then choose the project help or tutoring plan. We also have 3 and 5 month payment plans available. You don't have to pay all at once. And we also have invoices. If you have employer reimbursement for professional development, then we're happy to provide an invoice. If you want to book a call with us at any time, feel free. We're happy to answer any questions tonight or on a call, of course. And next, let's talk about the 8 weeks. So week 1, we introduced the blockchain ecosystem, kind of like we did tonight, but in more detail. Then in week 2, we start coding in Solidity with fundamental programming topics. In week 3, we start building our first smart contracts. In week 4 and 5, we get into more advanced contracts. In week 6, we build a cryptocurrency token and an NFT. Week 7 and 8, we learn how to deploy our smart contracts to Ethereum and how to manage more complex projects. We'll also talk about where to go from here and how to keep learning even after the course is done. And also how to get ready for the coding interview if you are interested in applying for a blockchain programmer job. So those are the 8 weeks. The next live class begins on September 8th. So you can currently watch back all the videos we already have because we've run this course 3 times already. And next live iteration starts very soon on September 8th. And registration closes in just a few days, so be sure to enroll before that end date. The course is 8 weeks, excluding any holiday breaks. The effort depends on your course goals. So if you want to just watch along, that's totally fine. There will be optional homework and challenges each week. If you do want to maybe start a new company or get a job by the end of the course. Gavin is asking, why doesn't the course promote or encourage the XRP? Let's see. Well, the focus is just on getting you to be able to build from beginner to advanced contracts. So we just kept a sole focus on Ethereum, but we do often update our courses depending on student demand. So if we do get a lot of interest in XRP, be happy to add that on. But currently, Ethereum is enough to get you up to speed. And then if you know one blockchain, you're going to find it easy to transition to another one because they all have similarities, though of course they have their own unique features too. XRP is another type of ledger, XRPL. You can read more at xrpl.org. So another type of blockchain, there are many blockchains that are being developed over time. XRP is especially popular in the financial industry. So I will drop a link for you to read more. So it's very similar to Ethereum, but it has its own language and its own unique features because it had its own extra features that it wanted to add to differentiate itself from Ethereum for specific purposes. So still a blockchain, you can still build contracts, but with XRP, there's a bit higher of a learning curve and they have fewer features at the moment. So Ethereum is the most established at this time. So there's more documentation and currently there's more that you can do on Ethereum. Gavin's saying XRPL is cheaper, less gas and good for the environment and the future of money and more. So yes, there are more blockchains developed every year, even more often with their own different core focuses of what they want to improve. Like Ethereum itself it was built specifically to improve on Bitcoin. So XRPL, another one, especially in financial smart contracts. Currently, Ethereum is the one that is easiest to learn and has the most support, the largest community. It also has the most well-defined documentation and the most built-out structure. So there's more defined ability to do different smart contracts and use templates, work with libraries currently on Ethereum. But great question. And yes, we'd be happy to add more blockchains upon demand. Like in Web3, we cover Ethereum, but we also do cover Cardano. All right, so in September, we're going to meet every Thursday at 5 p.m. Pacific or 8 p.m. Eastern if you're in the live classes plan or the project help plan. And we meet for 2 weeks, not for 2 weeks, for 2 hours every week for 8 weeks. So if you do want to enroll in a course, you can just click select course for any of the plans and it will be added to your cart. And don't forget, we currently are running a Labor Day sale. So I'll drop in the chat our coupon code for Labor Day. You can add more courses anytime. So if you want, you can go to a different course webpage and you can add on to your cart. The cart will be saved. So Web3, similar course in the same realm, same blockchain realm. And then you can proceed to the checkout. And you can choose if you want to pay with a payment plan or not. So you can pay over 3 months, 5 months, or all at once. And then just like that, you can place the order. And then you'll be able to access the course from your Lumiwealth account. And you'll also get a link to join the live classes. And then you just join that link at the appropriate time. The first will be September 8th at 5 p.m. Pacific or 8 p.m. Eastern time. And just like that, you'll be in the course. Real is asking, I'm about to enroll. Do you guys help with job placement? Yes, we do help with resume, interview, prep. We also partnered with a company that's looking for internships, and we're always looking for more companies like that. So yes, we do help with job placement. So those are the 8 weeks. If anyone has a question, please feel free to ask now. You can also direct message us on Circle at any time at lumiwealth.circle.so. You can also find us on Discord or email or book a call through the website. We're happy to answer questions anytime. To book a call, I will drop a link for that page. You do want to talk over the phone. You don't have to pay for 2 courses, definitely not. You can go to your cart and just buy one. It's totally fine. And you can enter any coupon code that you have, and you don't have to add any more. You can just proceed to checkout with one. Great question. So no, you can just have one course. That is it. And pay with a payment plan or not. And just like that, you'll be in. Thank you, Matt, and everyone else. Thank you for your questions. Happy to answer anytime. If anyone has a question about the blockchain, XRP, or the course, please feel free to ask away. Very happy to lead you all tonight. And I hope to see you in the fall. Starting in September, very shortly, we'll begin our live sessions for blockchain programming. Thank you, everyone. Stay tuned for our next webinar here at Circle. We do webinars quite often, so make sure to stay tuned for our events. Don't forget to follow us on YouTube, where you can watch back some of the webinars that we've done before. Real is asking, do you deal with JavaScript? In this course, we don't use JavaScript. We use Solidity, which has similar syntax. If you're interested in JavaScript, then look into Web 3. In Web 3, we use JavaScript for the entire course except the last week where we talk about a different blockchain. So yeah, if you're interested in JavaScript, then check out Lumiwealth's Web 3 course. It's along similar lines, but it covers different topics. It uses JavaScript primarily. Recruiter said something about JavaScript. JavaScript is a very popular language. About 97% of websites are built with JavaScript. And JavaScript is popular in the blockchain space for building decentralized apps. So if you want to build something like OpenSea, where you're building a website that is the user interface for people to communicate with a blockchain. To build a website like that, you're like the intermediary between the user and the blockchain, like the window. So to build this, you would have to use JavaScript. Nathan's asking for the link for YouTube. Yes, I have dropped it in the chat. You can just look for Lumiwealth on YouTube. Happy to help anytime. Hopefully now you all have more understanding of Bitcoin, Ethereum, cryptocurrencies, NFTs, and you understand more of the technical aspects and what you can do beyond just the hype and what's in the media. Great questions, everyone, tonight. And if no one has further questions, then feel free to go now. We've covered everything we need to cover. I hope you're all as excited about the blockchain as I am. And I'm looking forward to seeing you in the fall. If you do want to read the slides again, I'll drop a link to those too. You can also save the presentation, read it on your own time. All right, looks like everyone is out of questions, so we will call it a night. Thank you for joining me. Feel free to message me anytime, and I will see you in the fall.